In this lesson, we're going to discuss technical operations in the cloud. Technical operations refer to the processes and procedures that ensure the smooth and efficient functioning of a given cloud-based system. These technical operations are essential for managing and maintaining the various cloud-based services and resources that your organization rely on. As we delve into the realm of technical operations in the cloud, it is crucial to begin by examining the relationship between technical operations and cloud characteristics, service models, and deployment models. Starting out with cloud characteristics, we have on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured services. First, we have the key characteristics of on-demand self-service. On-demand self-service means that your users can quickly and easily provision and manage their own resources, such as computing power and storage, without the need for the IT staff to manually provision those resources. This feature enables users to scale up or scale down their resources as needed and allows them to be more responsive to changing business demands. Second, we have broad network access. Since cloud services are typically accessed over the internet, users can access the resources from anywhere as long as they have internet connection. This feature allows organizations to have a more mobile workforce because employees can access cloud resources from remote locations. This broad network access characteristic also means that organizations can expand their customer base by making their services available to a wider and more globally distributed audience. Third, we have resource pooling, which is another key characteristic in cloud computing. Resource pooling refers to the ability to share resources among multiple users and customers. By pooling resources, cloud providers are able to provide users with a more efficient and cost-effective way to access resources, since they are able to share the cost of maintaining and managing the resources. Fourth, we have rapid elasticity. Rapid elasticity refers to the ability to quickly and easily scale resources upwards and downwards as needed. By using rapid elasticity in the cloud, organizations are able to quickly respond to changing business needs and ensure that they have the resources needed to meet the variable demands of their consumers. And the fifth and final cloud characteristic is measured services. Measured services refers to the ability to monitor and measure usage of cloud resources and services. This feature allows organizations to better understand their usage patterns and to optimize their usage of cloud resources to minimize costs. This is really important when using cloud computing, since many cloud resources use a pay-as-you-go model. So tracking your resource utilization will ensure you understand your current and future costs and can also help to ensure that you remain within your allocated budget and constraints. Now, in addition to the 5 characteristics of cloud computing, we also have 3 cloud service models that you should be aware of. Infrastructure as a service, or IaaS. Some people actually like to say ICE. Platform as a service, or PaaS. And software as a service, or SaaS. Technical operations in the cloud play a crucial role in the delivery and maintenance of these 3 service models within the cloud. So let's take a quick look at each of them. First, we have infrastructure as a service. Infrastructure as a service is a service model where the cloud provider delivers computing resources such as servers, storage, and networking over the internet. Technical operations are responsible for maintaining and managing the underlying infrastructure, including the physical servers, storage, and networking equipment. These technical operations ensure that the infrastructure is secure, available, and performing optimally. A common example of infrastructure as a service, as we used prior, is Amazon Web Services. AWS provides customers with a scalable and flexible infrastructure platform in the cloud where customers can rent virtual servers, storage, and other computing resources on demand and only pay for what they use. This eliminates the need for customers to invest in and maintain their own physical hardware and allows them to focus on their primary business operations. Second, we have Platform as a Service, or PaaS. Platform as a Service is a service model where a cloud provider delivers a platform for developing, testing, and deploying applications over the internet. An example of PaaS, Platform as a Service, is a cloud-based service like Heroku. This service provides developers with the tools and resources to build, run, and manage web applications on the cloud. This includes hosting, storage, databases, server infrastructure, and other services that will make it easier for developers to focus on writing code and delivering their applications without having to worry about managing the underlying infrastructure. And third, we have Software as a Service, or SaaS. Software as a Service is a service model where the cloud provider delivers software applications over the internet. Technical operations are responsible for maintaining and managing the software applications, including the software, the database, and the web servers. They ensure that the software applications are secure, available, and performing optimally. A good example of software as a service is Gmail. Now, Gmail is an email service provided by Google that allows users to send and receive emails over the internet. With Gmail, users do not have to install or maintain email software on their own computers, but they can still access their email from any device with the internet connection. Finally, we need to discuss the 4 cloud deployment models and how technical operations are conducted within them. These models include public, private, community, and hybrid cloud deployment models. First, we'll start off with the public cloud. Public clouds are primarily managed through the dashboards and automation tools provided by the cloud service provider. These dashboards provide us with the ability to monitor, automate, and integrate various cloud services from a public cloud vendor into a single management tool that our organizations can utilize to conduct our daily operations and support the cloud environment. Second, we have private clouds. When it comes to private cloud operations, the skill set needed for admins shifts from managing individual servers to managing entire database centers. This means that operations roles needs to adapt and take into account the cloud technologies being used. Third, we have community clouds. Community clouds are provided by a group of organizations and are typically used by the organizations that have similar security needs and where the operation maintenance load can be distributed across all of the participating organizations. Fourth, we have the hybrid clouds. Hybrid cloud services are a combination of public, private, and community clouds, which allow the organizations to take advantage of the benefits of all these different cloud deployment models as part of their overall infrastructure and operations. So, in summary, it is important to remember that technical operations are essential for managing and maintaining cloud-based services and resources. By having a good understanding of the 5 cloud characteristics, the 3 cloud service models, and the 4 cloud deployment models, you can ensure your organization can make the most of its cloud investments and ensure that its cloud resources are being used efficiently and effectively over time.